I'm John Strum, and this is Real Talk MS. It's April 4th, and we have a lot to talk about. And today, we're talking about what may cause multiple sclerosis. How's that for an opening? If you've been listening to this podcast for a while, you know I never engage in hype, and I stick to talking about evidence-based outcomes and discoveries. So let me say right up front, the cause of multiple sclerosis is unknown. However, a research team has identified a bacterial toxin that may be the cause of MS onset as well as MS relapses. The science is sound. It's been published in the Journal of Clinical Investigation, but it's just the first step in what will require much more research to come. My guests today are Drs. Richard Rudick and Timothy Vartanian. Dr. Vartanian heads up the team that made this discovery, and you're hearing about it first in my exclusive conversation with Drs. Rudick and Vartanian. But before we get to that conversation, there are a few other things that you should know about. When we talk about stem cell therapy and MS, many, if not most people, think of autologous hematopoietic stem cell therapy, or AHSCT, which is a type of stem cell therapy. We've talked about AHSCT often on this podcast, but it's not the only type of stem cell therapy. And a team at Tisch Multiple Sclerosis Research Center in New York has reported promising results in a small stem cell study that used mesenchymal stem cell-derived neural progenitors. So first, let's break down what mesenchymal stem cell-derived neural progenitors are and what this therapy is about. This therapy is often referred to as MSC-NP because it's much easier to say MSC-NP than trying to say mesenchymal stem cell-derived neural progenitors. Mesenchymal stem cells are stem cells that can be found in a variety of tissues in the body, and they can mature into various types of cells. In this therapy, mesenchymal stem cells are collected from a patient and then programmed in the lab to grow into specialized stem cells that can become neurons and other types of central nervous system cells. These specialized stem cells are called neural progenitors. And because they're created from mesenchymal stem cells, they're classified as mesenchymal stem cell-derived neural progenitors. Now that we've gotten past our definitions and explanations, let's talk about what happened in this phase 1 clinical trial. The trial recruited 20 people with progressive forms of MS. 16 had secondary progressive MS, and 4 had primary progressive MS. Mesenchymal stem cells were collected from the bone marrow of each of the study participants. These stem cells were programmed to grow into specialized stem cells, the neural progenitors we just talked about. Each trial participant received MSC-NP, which is introduced directly into the nervous system by spinal canal injection. Each study participant received a total of 3 injections, with each injection coming 3 months apart. Now, MSC-NP has been shown to reduce disease severity and promote myelin regeneration in animal models of MS, and the outcome of this study indicates that it may hold similar benefits for people with MS. The results of the study showed that most of the 20 study participants experienced improvements in their functional abilities, and those improvements lasted at least 2 years in some of the patients. Encouraged by these initial results, the Tisch Multiple Sclerosis Research Center has a phase 2 clinical trial underway that will evaluate MSC-NP against a placebo in 50 people living with progressive forms of MS. They anticipate having results from this phase 2 study later this year, and we'll be sharing those results when they become available. If you'd like to review the details of their phase 1 clinical trial, you'll find that link in today's show notes. EDSS, or the Expanded Disability Status Score, is something that most everyone living with MS is at least somewhat familiar with. It's the scale that's used by neurologists to characterize the level of disability and, over time, the nature of MS progression for someone living with multiple sclerosis. The scale ranges from 0 to 10, and the lower end of the EDSS is mainly determined by the outcomes of a neurological examination, while the higher end, scores of 6 or higher, are largely influenced by mobility difficulties. Since its introduction in 1983, EDSS has become the most widely used assessment tool to classify disease progression in people with MS. But EDSS is not without its shortcomings or its critics, who point out that it doesn't adequately account for other aspects of MS, like cognitive impairment or depression. And the results of a newly published study point to how the limitations of EDSS could mischaracterize or understate the impact of MS on someone. In this study, a research team recruited 141 people with an EDSS score of 3 or lower. These people all had been living with MS for at least 10 years. The group consisted of 115 females and 26 males. The mean age was just about 51. And this group was given a series of 7 tests to assess cognition. The tests assessed memory, executive function, visual spatial processing, verbal function, attention, information processing, and motor skills. The research team also assessed the study participants' levels of fatigue and depression. The researchers also recruited 158 people who had been living with MS for 10 years or more, with an EDSS score higher than 3. They also recruited a third group of 487 people who had been living with MS for less than 10 years. And after these groups had been given the same battery of tests, the researchers compared the results. 38% of the people who had been living with MS for 10 years or longer and had EDSS scores of less than 3 were shown to have cognitive impairment, with the highest rate of impairment associated with information processing, while 66% of the people with an EDSS score of more than 3 demonstrated cognitive impairment. 77% of the people who had been living with MS for 10 years or longer and had EDSS scores of less than 3 were shown to be experiencing fatigue, and 55% of this group was also shown to be experiencing depression. And these numbers were about the same for the people with an EDSS score greater than 3. The research team concluded that cognitive impairment, fatigue, and depression, all of the invisible signs of MS, were common in people who had been living with MS for 10 years or longer, but had maintained a very low EDSS score of 3 or less, providing evidence that an over-reliance on EDSS can fail to capture the full and true nature of how MS is impacting an individual. Now, if you'd like to review the details of this study, you'll find a link in today's show notes. Living with progressive MS usually means living with some level of physical disability. But living with progressive MS isn't only about living with physical disability. It also means dealing with invisible symptoms like pain, fatigue, and cognitive impairment. Taking all of the symptoms of progressive MS into account, the International Progressive MS Alliance has established a new research pipeline designed to test innovative treatments focused on the well-being of people living with progressive MS. In announcing the first stage of this research pipeline, the Alliance has issued a request for applications for an initial planning grant of up to €100,000 for proposals that focus on 4 specific symptom areas: fatigue, mobility including upper extremity impairment, pain, and cognitive impairment. The International Progressive MS Alliance initially issued its call for prioritizing MS rehabilitation research in a paper published in the Multiple Sclerosis Journal in 2021, and I'll proudly acknowledge that it was my honor to be one of the co-authors of that paper. With the announcement of what I believe is the first of its kind research pipeline that's focused on well-being, The Alliance is backing up that initial call for research with an investment and a long-term commitment to the kinds of treatments that will make daily life better for people living with progressive MS. Now, if you'd like to learn more about this work, you'll find a link in today's show notes. And while we're talking about the International Progressive MS Alliance, if you missed their global webcast last week, you still have an opportunity to catch the replay. Entitled Developing Treatments to End MS Progression, the webcast features an outstanding international panel of experts discussing the current state of treatments for progressive MS, active clinical trials that may provide new solutions, and research efforts to develop breakthrough treatments to end MS progression. The webcast is well worth watching, and the video replay is available on demand. You'll find the link in today's show notes. Speaking of developing treatments, imagine how much easier it will be to develop a treatment that ends MS once science has identified what causes MS. Well, we may be a big step closer to that today, thanks to the work of my guests, Drs. Richard Rudick and Timothy Vartanian. In a moment, we'll be among the first to hear about this discovery from the scientists themselves. Dr. Richard Rudick's 30-year clinical practice experience includes serving as the director of the Mellon Center for Multiple Sclerosis at the Cleveland Clinic, as well as serving as the Cleveland Clinic's chief clinical research officer. Dr. Rudick's research has focused on experimental therapeutics, including innovative approaches to measuring immunologic, clinical, and imaging features of multiple sclerosis for use in both clinical research and practice. Dr. Rudick played a key role in the development of both Avonex and Tysabri, and in 2014, Dr. Rudick transitioned to a senior role at a major pharmaceutical company where he led work in identifying ways to enhance MS care through technology, innovation, and continuous learning. Dr. Timothy Vartanian is a neurologist and neuroscientist focused on understanding the fundamental mechanisms that cause demyelination in multiple sclerosis and defining new strategies to promote myelin regeneration in MS. Dr. Vartanian is a professor of neurology and neuroscience at the Brain and Mind Research Institute at Weill Cornell Medical College of Cornell University in New York. Gentlemen, welcome to the podcast.
Thank you, John.
We've known that an environmental trigger is required for MS to occur in a genetically susceptible individual. And Dr. Vartanian, you and your team may have identified that trigger responsible for the onset of MS and ongoing disease activity. Can you tell us about your lab's discovery?
Sure, absolutely. And thank you, John. So I'll put it in some context. Multiple sclerosis is defined by its lesions, but what causes those lesions to form is not known. The earliest events in lesion formation seem to be disruption of the blood-brain barrier and early signs of injury to myelin and the cells that make myelin called oligodendrocytes. But again, why this occurs has been a mystery. We know that MS requires an environmental trigger for the disease to occur, and so by definition, that means an environmental trigger is required for lesions to occur because lesions define the disease. Many years ago, in 1986, an Australian physician postulated that sheep pathogens might be causative for MS because MS occurred in high frequency in areas where there was a high density of ruminant animals. Amongst those organisms that were of interest to him was Clostridium perfringens. And he actually tested whether epsilon toxin was associated with the disease, but didn't find an association. His tools were, I think, inadequate to actually answer this question. So we've been interested for decades in trying to identify molecules, environmental or within humans themselves, that are specifically toxic to oligodendrocytes because we considered them a prime target of the disease and required for disease initiation. Epsilon toxin is attractive because it's known to target the blood-brain barrier and known to bind to myelin. So the first, I think, important advancement was when Rashid Ruma, a graduate student that I co-mentored with Vince Fischetti at Rockefeller University, was able to show that in the serum of people with MS, a higher frequency of antibodies directed against the toxin. And so that was an insight that provided evidence for prior exposure in MS patients to the toxin. And then Jennifer Linden, who was a postdoctoral fellow in the lab, in my lab at the time, Jennifer Linden was able to show that epsilon toxin specifically targeted the blood-brain barrier, and working with Yinghua Ma in the lab was able to show that epsilon toxin specifically targeted myelin and oligodendrocytes. So here we have evidence that there's antibodies to the toxin in the blood of people with MS, and that the toxin targets the two initial events in lesion formation, disruption of the blood-brain barrier and myelin. And that really compelled us to be all in and focus all of our attention on this organism and this toxin. And that's when Yinghua Ma worked with other people in the lab, David Sanino and Jennifer Linden, to develop a method for detecting the organism in the gut microbiome of people with MS by analyzing fecal samples. And Yinghua was able to show that about 61% of people with MS harbored these toxin-producing organisms in their gut microbiome, whereas only 13% of healthy controls did.
I'm always fascinated by the nature of discovery, and it makes me an amateur science geek, I suppose. But one of the things I heard you say, Dr. Vartanian, is this notion, this idea had been postulated some time ago, but there weren't the tools available to be able to accurately test and measure and arrive at some of these conclusions. So this sounds like a case of we were waiting for technology to advance to the point where we could have these tools that allowed you and your lab to do the work that you've done. Am I getting that right?
Yes, to a certain extent. At the time that Timothy Murrell, the Australian physician who first postulated the organism and potentially epsilon toxin as being associated with MS, there were actually reasonable tools, to interrogate serum and blood, and he used the tools that were available, like you said. Soon after that, I would say, not too long after that, the tools that were necessary to interrogate the gut microbiome for what was necessary to detect this organism did become available, but no one bothered to pursue this hypothesis. And as a result, it kind of just was left I would say untested in the strictest sense. And then what happened was even more modern tools became available. 16S sequencing, shotgun sequencing, all the sequencing technology that is used to do what's termed metagenomics, and that's the genomics of communities, in this case, the community of bacteria and other microbes within the gut microbiome. Those became available and then became mainstream. But those techniques, as it turned out, as sophisticated as they are, were not sensitive enough to detect this specific strain. And a more traditional technique, polymerase chain reaction, PCR, amongst other advancements, was required to detect this strain in the MS gut microbiome.
Dr. Rudick, over the past 50 years, several infectious agents, ranging from measles to Epstein-Barr virus, have been proposed as the cause of MS. Certainly, we've heard a lot about Epstein-Barr virus over the past 18 months or so. And when we talk about the Epstein-Barr virus on this podcast, I refer to it as a likely trigger, but not a cause. Can you explain what makes epsilon toxin producing strains of Clostridium perfringens or C. perfringens a more likely cause of MS?
Well, I'll do my best, John. I don't really know all the answers yet, but the way I think about it is that the EB virus, as well as other viruses, make the disease more active. They seem to stimulate disease activity. I liken it to pouring a little gasoline on a fire. But the viruses that stimulate activity in MS, we don't think they caused the fire. We don't think they started the fire. What we really need is we need to know, why did the fire start? And that's been a missing link in MS. It's a big mystery. The reason so many infectious organisms have been proposed as triggers, as agents that start the fire, is because the pattern of the disease looks like it could be an infection. And this has been the reason for this worldwide, decades-long search for an infectious agent. So EB virus is a very hot topic right now, and for good reason. It is associated with MS, but it's not sufficient to explain why MS gets started. The reason that we're very interested in the Clostridia hypothesis is because patients have this organism in their gut, and the toxin targets exactly where we would think an agent would act if it was starting the disease. In other words, starting the fire and keeping the fire going. So in short, we think there may be multiple risk factors that increase the activity of the disease, including EB virus, but we're still missing the cause of the disease, and that's why we're so excited about this.
Since we're talking about Clostridium perfringens as a potential cause of MS, the thing that starts a fire, to borrow your metaphor for a moment, Dr. Vartanian, your work has shown that it not only starts a fire, but it sort of plays a role as a fire burns, as the disease actually evolves. Can you talk a little bit about that role?
Absolutely. I think there are two concepts about causative agents in MS. One concept is that the agent appears or influences the initiation of the disease and then is not needed any further, is essentially gone. And that's sometimes called a hit and run hypothesis. The other hypothesis is that the environmental agent, which is causing new lesions to occur, causing the initial lesions to occur that define the disease, are the same, and that they're present throughout the course of the illness. There are so many characteristic features of MS, specifically targeting myelin in the central nervous system, the location of lesions around blood vessels, and the episodic nature of the disease, a relapsing remitting disease. What causes a relapse and what causes a remission? All of these mysteries actually fit kind of nicely with the epsilon toxin hypothesis. It's known that the characteristics of the MS lesion when it initially forms are the same, whether it's a new lesion that forms 15 years into the disease, or it's the lesions that formed at the initial event, the initial diagnosis. They have the same characteristics. The current research would argue that whatever triggers the disease to occur, those initial lesions to form, is the same thing or are the same things that cause lesions to form throughout the course of the illness. The episodic nature of the illness fits nicely with the episodic nature of epsilon toxin's growth within the small intestine and then its quiescence, essentially. The toxin is produced when the organism grows and is not produced if the organism is not growing. And that we know, at least in other model systems, occurs episodically. And Well, I think I'll leave it at that. So those features fit nicely with epsilon toxin as an agent that is persistent throughout the course of the illness, triggering new lesions to form, episodically.
Dr. Rudick, the relationship between the gut microbiome and MS has been the focus of several studies over the past few years. How has Clostridium perfringens stayed under the radar and not been discovered until now?
Well, I think the reason that the microbiome studies, is, to the best of my understanding, have not really shown this particular organism is because it's below the level of sensitivity of these metagenomic approaches to analyze the gut microbiome. So it would not be specifically identified unless you were looking for it. I believe that the Vartanian lab identified this association by highly specific PCR reactions that demonstrate the toxin in the fecal material. So it's not really surprising that the gut microbiome studies would have overlooked this. You have to be looking specifically for it.
Dr. Vartanian, what might this discovery mean in terms of potential therapies?
In terms of designing therapeutics for MS, the critical questions are, what are the most relevant targets to be going after? What's attractive about epsilon toxin as a target is that we hypothesize its function is at the very earliest stage of lesion formation. Other factors are likely important, clearly, but that if there isn't this initial event that's required for triggering lesion formation, then the lesions don't form. So having a known target that functions at the earliest stage of lesion formation is extremely attractive for developing a therapeutic that can neutralize that toxin.
This is certainly an exciting discovery. I always share my standard disclaimer with my listeners that there's quite a lot of difference between a mouse brain and a human brain, so lots more work to be done here. Dr. Rudick, what do you imagine comes next?
I think we need to do more research to show that the toxin is in the MS patient's body. Tim and his colleagues have demonstrated that the toxin is in the fecal material, but does the toxin get across the intestinal epithelium and enter the blood? Does it then attach to the target organs in the brain? For example, is the toxin or footprints of the toxin, are they there in the lesions of MS? So there's a series of research that's needed to really tie the toxin a little bit more directly to MS patients as well as to the pathology in brain. I think the step after that would be to determine whether some approach to neutralize the toxin as a therapeutic strategy would prevent the disease from progressing. And so those are the two most important steps.
Well, Doctors Rick Rudick and Tim Vartanian, thank you both for your years of work focused on deciphering the riddle of MS and improving the lives of people affected by MS. And thanks so much for talking with me today.
Thank you, John. Pleasure.
As interesting and exciting as I think this news is, both Dr. Rudick and Dr. Vartanian wanted me to be sure and stress that there's a lot more work to be done here, and we'll see that work taking place over the next few years. But I think they may be onto something important here. If you'd like to review this research, you'll find a link in today's show notes. And that's going to wrap up this episode of Real Talk MS. Real Talk MS is powered by the National MS Society, and you can share this episode of the podcast by letting your friends or family members know that all they have to do is point their web browser at realtalkms.com/292. You'll find that link in today's show notes so you can easily copy and paste it right into an email or a text. And if you have a minute, I hope you'll visit the Apple App Store or the Google Play Store and download the free Real Talk MS app for your iOS or Android smartphone or tablet. It's the best way for us to stay connected. The app will automatically download the latest episode of Real Talk MS. You'll be able to access any of our past episodes. You'll be able to save your favorite episodes. And it's a great way for me to share bonus content with you. The app is free, so I hope you'll download it today. I'm John Strum. Thanks for listening. Stay safe and make healthy choices.